Hello everyone. Today we are diving into Leetcode problem 1482, minimum number of days to make M bouquets. So in this question, you're given an integer array bloom day and you're given two more integers M and K. So M represents the number of bouquets that you need to make. You will make those bouquets using the K adjacent flowers that are present in the garden. So each of the bouquets have to be made using the K adjacent flowers. So for example, you're given two bouquets to make. Okay, you're given two bouquets to make. So the value of M is 2, and each of the bouquet needs three adjacent flowers. So it means the value of K is 3. For example, I'm making my imaginary garden. These are the flowers. So I have to make one bouquet using three adjacent flowers. So I can make bouquet using these three adjacent flowers, or I can make bouquet using these three adjacent flowers, or I can make bouquet using these three adjacent flowers. One bouquet using these three adjacent flowers. But you cannot make a bouquet using this flower, and this flower. The flowers need to be adjacent, or you cannot make a bouquet using these two flowers and one flower from here. You have to make the bouquets only using adjacent flowers. And how many adjacent flowers? K adjacent flowers. The value of K will be given to you. And how many bouquets do you have to make? M bouquets. So each of the bouquets have to be made using K adjacent flowers. Now, the thing is, the bloom day for different flowers is different. So you cannot have all the flowers at once. You will be having N flowers. You will have N flowers, but the bloom day is going to be different. And the bloom day of the ith flower is given in the array. It's the bloom of I. So bloom of the ith flower is bloom of I. So we have to return the minimum number of days that we need to wait to make M bouquets. And if it is impossible to make M bouquets, we return -1. Now let's first focus on the case of impossibility. When will it be impossible to make M bouquets? So it will be impossible when the number of flowers that are available to us is less than required to make M bouquets. So what are the number of flowers that are required to make M bouquets? So K flowers for each of the bouquets. The total number of flowers that we need to make M bouquets is M times K, isn't it? So if the size of the array is less than the number of flowers that are required to make M bouquets, then we simply return -1. So we are done with this case. Now let's discuss how do we return the minimum number of days that we have to wait in order to make M bouquets. So let's start with an example. So this is the example and the bloom day is given to you. This is an array that's been given to you. So the bloom day for the first flower is the first day itself, and the bloom day of the third flower is the first day only. The bloom day of the second flower is the day 3, and for the rest of the flowers is given to you. For this flower, the bloom day is 4. For this flower, the bloom day is 4 again. For this flower, the bloom day is 3, and so on, as you can see. And we have to make two bouquets, and each bouquet should consist of 3 adjacent flowers. So I've just depicted day 1. So on day 1, we have got two flowers blooming, the first flower and the third flower, as you can see over here. We can draw a reference line like this. So let's talk about day 2. So obviously these flowers will be blooming and new flowers will come. So this flower was blooming on the second day, so it will start blooming now. And this flower will start blooming as well. So on day 2, this is the condition. Yeah. Do we have 3 adjacent flowers now? No, we don't have 3 adjacent flowers. We still, like, here we have one missing. Here we have got 2 adjacent, but we need 3 adjacent, right? We need 3 adjacent flowers in order to make a bouquet. So now let's move ahead to day 3. Let's see on day 3 if we can have 3 adjacent flowers. So obviously, the flowers that were already blooming will be there on day 3 as well. And on day 3, these are the new flowers that will be blooming. On day 3, this guy is gonna bloom, and this guy is gonna bloom. This guy is gonna bloom as well. We have got 3 adjacent flowers here, so we can make a bouquet from here. And we have got 3 adjacent flowers over here, so we can make a bouquet from here as well. So day 3 is gonna be the minimum number of days that we have to wait in order to make M bouquets. Let's see what happens on day 4. So obviously all the old flowers will be blooming, and on day 4 this new flower will start to bloom, and so will this new flower. So all the flowers will be blooming after day 4 is completed. No, we can still make M bouquets here, right? We can select these and these, or we can select these and these, or we can select these and this. So there are multiple options that we have. So the minimum number of days that we need to wait is 3, not 4. Even though on day 4 we can make the flower, but the minimum that we have to wait is for 3 days. Now, how do we implement this question? Logically, what we can do is we start from day 1 and we loop through all the days and check if M bouquets are possible or not. So let's see the coding implementation of the above problem. So what we were doing is we're seeing day by day and every day new flowers were blooming. And if on any day it is possible that we can make M bouquets using K adjacent flowers, then we return that day as answer. So what we do is we start from day 1. We start iterating from the first day and we keep on going until we find a possible day and which keep on checking. So first of all, we will check for day equals to 1. If it is possible to make M bouquets using K adjacent flowers given the bloom day array in 1 day, so the value of day will be 1, then we return 1 itself. If it is not possible, then this loop will make it 2. If it is possible to make it in 2 days, if it is not, fine. If it is possible to make it in 3 days and 4 days, and we keep on checking if it is possible to make M bouquets using K adjacent flowers given bloom day in a certain amount of day. If it is possible in this much days, we return that. Now the question is, where is this function coming from? Is possible. So let's see the implementation of this function. So let's talk about the is possible function. So we are this function checks if it is possible to make M bouquets with K adjacent flowers given the bloom day for each of the flower in D days. So this D is basically these days that I'm putting. So if it's possible in 1 day, 2 day, 3 day, this loops keeps on checking. Yeah. And this function is called every time when this loop checks. So if it is possible to make M bouquets using K adjacent flowers in D days. So first of all, we need a count of the bouquet, right? So let's initialize a variable bouquet count. And initially it's 0, right? And we need to check how many adjacent flowers we have used so far. So let's call it adjacent count. And let's initialize it with 0 as well. Now we will loop through the elements of the bloom day. And for every flower, we will check its bloom day. Yeah. And if the value of D, if it is greater than the bloom day of a particular flower, then we take that flower into use and we increase the count of adjacent. And if the count of the adjacent becomes equals to K, if it becomes equals to K, then we can make a bouquet, isn't it? So we increase the count of the bouquet. We reset the count of adjacent flowers to 0. And if bouquet count becomes, after this increment, if the bouquet count becomes equals to M, then we simply return that yeah, it is indeed possible to make M bouquets using D number of days. However, if D is not greater than the bloom's day of I, it means the flower has not bloomed yet. Then we have to reset the value of adjacent count to 0. This is important. Everything else is fine. And thus our for loops end over here. And if the return true statement is never reached, it means the bouquet count has never been equals to M. If return true has never been reached, then we return false. So this is the implementation of the is possible function. So let's discuss the C++ code of the above problem. So first of all, we will define the number of flowers available to us. So n is the number of available flower. After that, we define the required flowers in order to make M bouquets. That's M times K that we have already discussed. And in case the required flowers exceed the number of available flowers, we will return -1. This was our first check. And if the condition doesn't fall in this case, then an answer exists for sure. So we will define infinity as a very big integer. Let's call it int max. And then we will start looping through the days. And for every day, we will check whether it can be the possible answer, whether it can be the minimum number of days in which we can make m bouquets. So we'll start with day equals to 1 and we will go till infinity and we will keep incrementing the day. And if it is possible on a certain number of days that we can make m bouquets with k adjacent flowers, then we will return that amount of day. And since an answer exists for sure, this will return your answer. Your answer will be returned here for sure. However, we have written this customary line, but this code will never be executed. Now, let's discuss the isPossible function. So, isPossible function has been written down exactly like we discussed in the pseudocode. We will first initialize the bouquet count and the adjacent count with 0, and then we will loop through the bloom day array. And if the days that we have taken, if it exceeds the bloom day of I, it means that flower can be taken. So we will increment the adjacent count. And in case adjacent count becomes equals to k, we can make a bouquet. So we increase the bouquet count and we reset the adjacent count to 0. And if the bouquet count becomes equals to m, we will simply return true. However, if the day that we have taken as our answer doesn't exceed the bloom day of that flower, it means suppose we were getting flowers like this, but this flower's bloom day is somewhat greater than the day that we have taken. So we were having the adjacent count as 3, but as soon as we cross this, the adjacent count becomes equals to 0 again. And after coming out of this for loop, if this return true statement is never executed, we will simply return false. Now let's see and submit it. So I'm just going to paste the code. So this is the code over here. Let's run it. As you can see, all the test cases are accepted. Now let's submit it. Now it will not be accepted because our solution is a brute force solution. So we will get a time limit exceeded because we are looping till infinity. And every time we are checking. As you can see, when the value of the bloom day is very large, it's 10 power 9, we are getting a time limit exceeded. So now let's think of a better solution. So what was wrong with this approach was this part. Yeah, that was a complete brute force because we were searching for our answer one by one in a linear search fashion. Now, as you can see, the linear search is not a very effective method of searching. We are searching our answer through linear search and we are going from 1 to infinity. So our time complexity will be very high when the number is somewhere around 10 power 9. As you can see, we got time limit exceeded when the elements were very big. So what's better than a linear search? It's the binary search. We can search our answer through binary search. Everything else will remain same. So let's write the standard binary search code for searching our answer. So let's discuss the binary search approach. So let's initialize our answer with some integer. So let's initialize it with -1 only. In binary search, we define a low and a high. So our low, so the lowest minimum number of days that we can get is 1, and the maximum value that I can get, let it be infinity, or let's just call it int max. So the standard binary search code looks like this. While high is greater than low, we'd find a mid. Now it could be it can be found out like this. And we check if this mid can be our answer. So let's check if it is possible to make m flowers with k number of days. We have got the bloom day array, and if it is possible to make this in middays. Yeah, and if it is possible, then our answer is gonna be mid, and we reduce our search space to mid -1. Now the answer varies from low to mid -1. Yeah, Otherwise, what we are going to do is, it means we need more number of days. So we reduce our search space from the left side and we say low is equals to mid plus 1. So the answer varies from mid plus 1 to high if the answer doesn't exist. And finally, we're going to return the answer. So that's how our binary search code will look like. So let's modify this code of ours to binary search code. We just comment out this linear search part. And let's write down the standard binary search code. So our high is going to be infinity. Our low, the lowest answer that we can get is 1. Yeah. We check if this mid can be our answer. If we can make M bouquets in mid days, then our answer could be mid. So we update the answer as mid. And let's just declare the answer over here. After that, we reduce the search space. If it is not possible, then we need to find the answer that is greater than the mid. And finally, we return the answer. So this is exceeding the maximum integer when we are doing high plus low, because high is already infinity and we are adding low to it. So it will exceed the allowable integer value that 32-bit integer can take. So what we are going to do, we are going to do a smart work over here. So instead of writing high plus low over 2, we're going to write the same thing but in a different fashion. We're going to write high minus low over 2. So the same thing, but it will not ever exceed the maximum allowable integer because it's high minus low and not high plus low. Let's submit it. So this required number of flowers is exceeding the allowable signed integer value. So it's exceeding the maximum allowable signed integer value. So we're going to change it to long long. So that's it. I hope it helps.